Hi everybody, this is AP Chemistry Chapter 5, Lesson 1, and we're going to talk about the ideal gas law, which is really a combination of Boyle's law, Charles' law, and Avogadro's law. So when all the variables are changing, or you're just trying to get, you have like 3 pieces of information and you're trying to get the 4th. So this is the infamous Pivnert. The ideal gas law is PV equals nRT, where P is your pressure in atmospheres. It must be in atmospheres when you use this equation. V is your volume, and that must be in liters. It must be in liters when you use this equation. N is your number of moles. R is your universal gas constant. It is a constant. Whoops. I think your AP table rounds it. It's the 0.08206 liter atmospheres per kmol. Okay? That is why, because these units for the gas constant are liters times atmospheres divided by Kelvin times moles, you need to have your pressure in atmospheres so that cancels out, and your volume in liters so that cancels out. And T is your temperature, and that has to be in Kelvin. So given the volume and temperature and pressure of a gas, you can find moles. Given temperature, moles, and volume, you can find pressure. So this allows you to calculate a characteristic of a gas at a given set of conditions, not in which we're changing. The equation expresses conditions of ideal behavior. Gases behave most ideally when the temperature is high, when they're spread out, and the pressure on them is low. So the equation expresses gas behavior under conditions of high temperature and low pressure. Gases will deviate from this law, okay? They deviate from this law when the opposite conditions are true. Okay, so they tend to deviate from this law when they're cold, so when the temperature is low, and when the pressure on them is high. So gases deviate from this law under conditions of high pressure and low temperature when you smush them. And it's worth mentioning that this pressure is not the pressure of the gas, it's the pressure on the gas. Okay? So when you have these conditions, the molecules become sticky and they start to clump together and take up space. An ideal gas is hypothetical. Most gases, most gases behave ideally under most conditions, typically when the pressure is smaller than 1 atmosphere of the gas. And the gases that are most likely to behave ideally are the lightest gases, hydrogen and helium, and also the non-polar gases, because they'll have the least attractions. Okay. So let's try, we'll walk through one example and then we'll do the rest of these in class tomorrow. So a sample of hydrogen gas has a volume of 8.56 liters at a temperature of 0 degrees Celsius, which is 273 Kelvin, and a pressure of 1.5 atmospheres. Calculate the moles. So simply we're going to use Pivnert. PV equals nRT. You're going to make sure everything's in your proper units. If not, you would convert them first. So that's atmospheres. Your volume is 8.56 liters. They want to know moles. Gotta move over. Your R is 0.08206. Sometimes, I think your AP tables gives it at 0.0821, so if you want to get in the habit of using that, you can. And then your T is 273. So you just solve for your moles. You just plug it in and solve for your unknown. Solve for X. Pretty straightforward problem. They are not always straightforward. So 1.5 times 8.56, 12.84. equals 273 times 0.0821, 22.4133x. Divide this side by 22.4133 and this side. And so the number of moles of gas present. Bye guys, we'll see you.
Yes, that's exactly. Okay, I will.
Is equal to 0.57 moles. Okay? And that is your answer. The key to doing these problems is really listing out exactly what you're given and then writing down your equation and plugging things in. I do like to use my units in my equation. I did not here because I was limited on space. But I like to keep the units in to make sure that they cancel out. Then you know you set everything up right. We're going to do more practice with Pivnert tomorrow. I hope you enjoy the practice tonight with Boyle.